So just to preface this, C++ was kind of abandoned at some point, maybe like 10 years ago, as a teaching mechanism, partially because it's as complex as it is. As an oversimplification, it basically has like every feature of every programming language that you've probably used as an undergrad. It has like it has the really ugly pointer stuff from C and the syntax from C, but it also has all the really strong object-oriented features of something like Java, with some extra things that Java can't do, like multiple inheritance. And the complexity itself is actually one of the reasons why it's used in such complex systems. C++ is usually the standard for really complex APIs like game engines, and some OSs like Windows 10 SDK is in C# and C++ and things like that. And because it gives you access to pointers and you can get pretty low level, it can also be made to be very performant, unlike something like Python, where everything is an object, and so any Python program will use a ton of RAM. So C++ is great for complex performance systems that need to interact very well and run at a decent rate. So games have to run at a certain frame rate, and Windows has to run at a certain speed and things like that. It's also used in IoT, Internet of Things. So if you're having your watch communicate with your phone and your refrigerator and your tablet, C++ and C, because they tend to work on most devices, are the languages of choice for that kind of thing. And even in languages like Python, libraries that you may be familiar with, like NumPy, are actually written internally with C++ because it performs so well. So C++ is an important language to know, but it was kind of just abandoned because it was too hard to teach with it. You spent so much time just trying to figure out how to do the most basic things that the high-level material that you're trying to teach kind of gets lost in the details. So anyway, I'm not going to go over every feature of C++, and I don't think it's worth doing that anyway. I believe in example-based learning, so I'm basically going to be redoing my VR lectures from the 590 class, but in C++. So these down here, where we did things like have a gun that could shoot, we had teleportation, we had a bunch of different ways of grabbing things, like or telekinetically grab things with your hand, magnetic grabbing, things like that. And so in implementing these in C++, I actually find that the flow of these lectures that were done in Unreal's blueprint system actually touch on details that don't normally get touched on in your average YouTube C++ lecture, that are actually really important. So I don't know, maybe it'll be helpful to have this lecture in general. Also, you should note that so if you decide to study C++ from a textbook, a lot of the details are actually not applicable to something like Unreal, because Unreal has its own classes that are wrappers for C++ classes, and Unreal also tries to stop you from doing stupid things, so it disables some of the more crazy experimental features of C++. So a lot of details that you might learn from a textbook are actually not useful for Unreal specifically. They might be useful for other C++ projects. And yeah, anyway, I think we'll learn best from practice. So I guess I will kind of assume that. So some people who joined are from the 590, so they already know how these lectures went. If you're not familiar with them, it's fine, because, well, I still have the original class example from those lectures, and I will be comparing the C++ to the blueprint that I used, but you don't actually need to know the blueprint. Like, if you follow along, you might get it, you might not, but if your goal is not to learn Blueprint, then it doesn't matter one way or another. Anyway, let's create our project. So I'm going to use Unreal 4.24 because that's the latest one that I have installed. Also, you can stop me if you have questions. Fortunately, I have an i9, so it doesn't take that long to compile anything.
Nice flex.
Well, it's not really a flex because I'm borrowing this machine from the department. If anything, it's the opposite of a flex. Well, now it is. Okay, where did my Unreal window go? Oh, there it is. It popped up for a second. Alright, so at least for the newer versions of Unreal, when you start the project, you'll get a window like this where you can create different types of applications. Like Unreal has become general enough that it's used for things like movies and architectural visualizations and things like that. I'll use games because we're doing games, and most of these templates that they have actually do have a C++ version. So the first person template does have a C++ version. So there's Blueprint and C++. The VR template, unfortunately, only has a Blueprint one. So that's kind of unfortunate, but it's fine because in the original lectures, I just made my own VR pawn anyway. So I'm just going to expand off of the first person template, and I'll use the C++ version. And actually, just in general, if a good way to practice developing in C++ is to compare the Blueprint implementation of these template projects to the C++ version. If you're one of the people who did the 590 assignments in Blueprint, that may be the easiest. If you know Unity, then maybe it's not as useful, but you know, it's still worth doing. It's worth understanding how to do the same thing in multiple programming languages in general. Anyway, when you choose a template, you can choose between Blueprint and C++ if it has both of those options. I'm going to make it scalable quality just so that I don't crash something. I don't think it will matter with this GPU. Desktop and console is fine. If you initialize a project with mobile or tablet, it creates these little joysticks so that if you build on a phone and push it to a phone, it would already work with the touchpad. You would have these joysticks that you can pull and it'll just work. But we don't need that. Scalable 2D, ray tracing disabled. I'll use the starter content simply because I want to use some of their materials. The starter content has some really simple meshes like chairs and tables, and materials like metal and wood. And I don't know if it has anything else. I mean, it has like the textures that you would need for those materials, like it has wood textures. I think it has the skyboxes and things like that, but let's not worry about that. I'm gonna call this project let's say UE4 C++ example. Create it, and if you you need Visual Studio to compile anything in C++ in Unreal. If you installed the engine, you probably installed Visual Studio, but if not, I believe I already have Visual Studio installed, so I actually don't need to worry about this, but I believe if you don't have VS installed, at this screen it will show you a little message at the bottom saying you need to install VS, and it will give you a link that has pre-configured Unreal settings which you can click and install with. So yeah, VS takes a little bit of time to install, as does Unreal, so you want to do those well before a deadline at least. But afterwards, it's not so bad. Well, they're both pretty hefty applications. I mean, they both use a ton of RAM. Like, VS is actually pretty good. I have a different VS project open. Yeah, I have two VS projects open, but you can see they both use like a couple hundred megs of RAM. The Unreal always uses a ton of RAM. It's a RAM hog like Chrome. There's not really that much you can do about it. and Epic Games Launcher itself is a piece of garbage, so I'm just going to close it. So I use the first-person template, and the first-person template in C++ and Blueprint looks the same. The scene layout is exactly the same. The difference is that, oh, this isn't even, oh, this is it, okay. I thought I had the other project open. The only difference is that the character is not done in Blueprint anymore. So in the original demo, you had, oh, this is the VR template. In the original version of this app, you had something called motion controller pawn. At least in the VR template, you had like a motion controller pawn, and it had a bunch of pre-built Blueprint code that you could use for various things. The first-person character has the same thing in Blueprint. Now it's in C++. So you can click here to edit, and the only thing that I believe has code right now are the first-person character and his bullets. You can see your own C++ classes that were used for this project down here. If you have a C++ project, it will create this folder for you that has all of your C++ classes. So you can see it has the character, which corresponds to this, game mode, and their projectiles. This is the equivalent of these files in the Visual Studio project that opens up. So you can edit these in Visual Studio here. You can open them up. You have header and C++ files, which I'll explain in a second. And in terms of the directory itself, like where it is located in your Windows file system or Mac file system, you can, just like with Blueprints, you can right-click any of these and go to Show in Explorer, and it will show you where they are in Windows Explorer. So the main difference between a Blueprint and C++ project is that a C++ project will have this extra source directory, which has your C++ code, and it also creates a Visual Studio solution. In a regular Blueprint project like this one, you don't have those. You just have the U project, which is what you use to open the Unreal project. Build I made myself, and these other things are the same between C++ and Blueprint. So C++ project adds these two things. So anyway, moving on. I'm going to create my own VR class. I'm not going to use their first-person character, but just to introduce you a little bit to how C++ works. This first-person character, okay, they have a blue coloring here where it says type. So that means that it's wrapped by a blueprint right now, but you can see the blueprint actually doesn't have any code. It's only being used to position things. The actual C++ class is here. And in C++, it's very similar to C, where you have header files and body files. In the header, it's pretty good practice to put all of your include statements in the header itself. In Unreal, specifically, you have this .generated.h file, which the engine itself generates. You should never touch this. And it also needs to be the last include, but that's a detail that's not that important. If you don't have this as the last include, it'll throw an error, so it'll be obvious when you don't. The header also includes the basic class information. So here we have my project name example character, which is this first-person character. It is extending a class in Unreal called a character, which is, okay, so a character is a subclass of a pawn. A pawn is an actor that is meant to accept any kind of input, like it's an NPC, like some kind of player of any type. It can be an AI player, it could be yourself. A character is an extension of a pawn that can move and has physics information. I believe those are the two main things that it adds, but it's not really important because we're not going to be using it for these tutorials. Just like with any other programming language like Java or C, you can right-click on these things in the IDE and go to like the information about this class. So for a character, I can right-click it and say go to definition, and it will show me I can go to the engine definition of characters if I want to see what is being inherited. But enough of that because we're not going to be using character. I'm going to move on. Generated body is something that Unreal throws in there, and the header will also include variable declarations and macros, which we'll see more of soon. In C++, you don't say, when you're declaring something like a float here, you don't say public float base lookup rate. Instead, you have a public section like this, and everything below it until the next section will be public. The commenting is the same as in Java or C, and you have public and protected and private, which you already know. All that really changes is the structure. So, you have these sections instead of public, void, or whatever. This class is very complicated, so I don't want to get caught in the details because we're not going to be using it. So this is the header. You also have a body file. In C, you just have a .c file, right? In C++, you have .cpp, but they serve the same function. They are the body of your functions. They are the actual code. So here is the constructor, which you can use to initialize a bunch of things. Again, I'm not going to get caught in the detail of this particular character because it's not important to us. You also have each of the functions. So like begin play was declared in the header. Here it's a virtual function because this is a subclass of actor, which has a begin play already. So you have begin play, and then all the other functions are defined here. And it's different from, it's C style. So instead of wrapping everything inside of like curlies for the entire class, in the C++ way of doing things, you do it this way instead. So you have the return value, then you have the name of your class, and then you have the function name, and then the curlies. So things are declared like this instead of being encompassed in one giant set of curly brackets like in Java. If you have any questions about that, you can ask, but I don't want to get caught in the details of this character. I just want to show you the structure. So moving on, I'm gonna ignore this class completely and just use my own pawn. So I want to also, just so you know, the first person character class, it's this guy that you can walk around and has a crosshair, and you can shoot these balls. The physics right now, I think it's physics accuracy. But again, we're not using this guy, so it doesn't matter. I'm gonna get rid of him. I want to make my own class, so here at add new, where you would normally create a blueprint class, like if you were in content, you can create blueprint classes and materials and things like that. If in C++ classes, you can do add new C++ class, and you have some options for the basic classes in Unreal. You have your character, which I mentioned it's a pawn that can walk around, and it has some physics stuff. A pawn is just anything that can, it's just anything that can do anything. It's like anything with intelligence, I guess. Although you can have some really dumb NPCs, so I don't know if intelligence is the right word. It's just something that can be controlled. Like an AI is controlled by itself and its logic. You can control your own pawn and things like that. Actor, if you recall, is it's the most basic Unreal class that has a 3D transform. It's it's basically the equivalent of Unity's game object. Components are, actor component is basically the same as a component in Unity, like a script that you add to something. A scene component is a component that also has a transform relative to the parent, and then you have other things like the HUD. It's not important because, or it's not important for this lecture because for the sake of following this original VR lecture, it's really not worth going over. You can also click show all classes to show every single class that you can possibly extend from the engine. Anyway, moving on and not getting caught in the details too much. I chose pawn because I just want the most basic VR pawn that you can have. I'm going to call it, I want to keep its name the same as what I used before, so in case I have to copy code. VRCPP pawn. And this is the name that I gave it. If you have modules like plugins that you're creating for other people to use, you will have other options here, but here it's just runtime because it's just my game. You can choose public and private if you want to. What this will do is split the source directory into, instead of having all of the CPP and header files in the same directory, it'll split them so that the header files are in a directory called public and the CPP files are in a directory called private. The reason being that if you're trying to publish code for other people to use, you want them to see the header file so that they know the definitions in your class, but maybe not exactly how it's implemented. And the CPP files would get compiled into like a DLL or something that other people can import without seeing your code. It's like if you want to make your code private, like if you want to make code for other people to use but you don't want them to see how you did it, you would do it that way. It's like how Java compiles its stuff into objects, and hopefully you know more or less why you would make code private. Anyway, I'm going to create this class, and it will do this, where it creates the file and then it compiles it for the first time. You can do this in a blueprint-only class as well. So, just to, Soria is not actually here, but I mentioned that this was a blueprint-only class. You can see it doesn't have a source or a solution. This is a blueprint-only project. You can turn it into a C++ project by simply adding a C++ class. So in this project you can do add new, and then there's new C++ class. And once you create your first C++ class, it will create the source and solution files for you. Anyway, here's my VRCPP pawn. You can double click it and it will open it. Just like in Unity, when you create a script, it will autofill it with begin, play, and start. Not the constructor, because the constructor is not useful in Unity, but just like how Unity autofills things with begin, play, and what is it called in Unity? Unity has start and update, right? So Unity has start and update, and it autofills some empty functions. Unreal and C++ will do the same thing. So it creates a header file for you that has just these things, and then it creates the body. Just to go over this quickly, Pragma wants, I actually don't remember what this does, but you shouldn't touch it. It has some basic includes, so core minimal, it basically imports the most basic things that you need to get an actor working in Unreal, and because I'm extending a pawn, it also includes the pawn class. Unreal C++ is, it has kind of specific naming conventions that it likes to use. So anything that is a derivative of an actor gets prefaced with A, or it's prefixed with A. And so my VRCPP pawn, I called it only this, but because it's extending an actor, they added the A for me. I guess it makes sense. It makes your code look kind of uglier than it needs to be, but that's the way that it is. Things that are not actors are usually, well, things like components usually start with U. So game objects. Maybe everything that's not maybe everything that extends in an Unreal class at all starts with A. I don't remember exactly their naming convention. Things like enums I think always start with E. Things that are not Unreal classes start with U or something like that. It's not really important because they handle this automatically. So they have this class definition. So the actual class header is pretty similar to what you would see in Java. They add this macro U class right above the class, which is used to tell the compiler that this thing will need to run inside of the game engine. If you remove U class, what will happen is that you won't be able to put this into the scene. Like right now I can throw my pawn into the scene and it doesn't do anything, but it is there. If I remove the U class, it won't work at all with the 3D scene. Like I said, it automatically generates this generated body part. It creates the constructor, which is public. It protects the begin play method because really nothing should ever call another object's begin play. This is something that's part of the actor lifecycle. And tick, technically nothing should call tick either, or either of these functions. These should probably all be protected, but anyway, it automatically made it public. Anyway, this is the header file. And it has these default functions declared. In the body file, you can see that they create the functions themselves and their bodies. So the constructor doesn't do anything except tell the thing that it can tick. Begin play doesn't do anything except call the parent's begin play. Tick doesn't do anything but call parent tick, and so on. We are going to move on to things that are more interesting than this. So the VR pawn, maybe I should show you what we're actually trying to create first. So we are trying to create this demo that I made in class in Blueprint, where you can do things like shoot and grab different objects in the scene. So if I test this, I can shoot a gun and it will turn these little blocks different colors. I can grab things. Well, I can teleport around by clicking. I can grab things like this and throw them. I can use force grab to grab things. We had force grab that snaps it to your hand, and there's also force grab that keeps it at a distance. And there's magnetic grip, which grabs the closest object to your hand. And the last feature was that you can shoot the blocks. So I can grab something, put it on my gun, and then shoot it. My triggers are barely working. This controller is breaking, but you can shoot blocks. And so we're trying to create this, except in only C++. This was the class demo that I made to show some basic VR functionality. So we're going to try to create this. Move this out of the way. The first thing we need to do is create the VR structure. So you will remember if you were in the 590, otherwise you should look at those lectures, but a VR character has a very basic structure of there is a scene component, which is the tracking center. So if you're using a Vive, it'll be the center of the Guardian when you do room setup. If you're using an Oculus, it'll be the center of the Guardian. I don't remember. The Vive is not called the Guardian. I don't remember what it's called. The Oculus is called the Guardian, but it's just like this grid that you put around you to describe how big your physical space is so that you don't run into anything. So the VR tracking center is just a single point that describes the center of that area. I can show you actually. So here's Steam VR. Display VR view. You may not actually be able to see it anymore. They used to have this thing. I think they removed it. There used to be this thing where you could see the entire setup of your space, but you can't do it anymore, I guess. Anyway, the tracking center is in the middle of your tracking space. The camera is where your head is as the user. So, you know, where the headset itself is in the space that you have defined. And siblings of the head are the two controllers. In Unreal, these are motion controller components. See motion controller component. And you have a left and a right controller. In Blueprint, it's very easy to define these because they're just there. So you have motion source, left and right. You can add these very easily by just doing add component motion controller. In C++, we'll see it's not that easy. But anyway, this here is the most basic VR character structure. And in my class demo, I also added a bunch of other stuff, which we will try to replicate. When you create a Blueprint class, like if I create a Blueprint version of Pawn, it actually creates things like the default root for me. In C++, it doesn't do that. They're not as friendly. Oh, I should have kept that as an example. The C++ version of pawns are not as friendly. They literally have nothing. It is quite literally just an empty class that doesn't even have a transform yet, because I haven't defined any kind of root for it. So we're gonna have to do that ourselves. So we will do that in the header. So here, I'm gonna put the protected part down here just so that it doesn't get in the way. I don't really care if it's protected. I'll just make everything public as God intended. I need to create these things from the class example. So I'm going to put these side by side just so that you know what I'm trying to do. Okay, first thing is we'll need a VR tracking center, and this is a scene component. In C++, the C++ name of things is pretty close to what the Blueprint name for them will be, just with this naming convention of adding A or U or whatever. So we are going to use the C++ scene component. The scene component is called, it does start with a U, so it's a U scene component star. And star because from 590 I mentioned that all components are always pointers, because Unreal doesn't like when you handle these things yourself. Like you can't make it an object like this because Unreal handles the initialization of components itself. So this will be a pointer. And it's using components, I called it VR Tracking Center. So it's already complaining, but that's fine. Let's just compile it quickly before I add anything else to make sure it actually compiles. It's probably going to get upset that I didn't import something, but we'll see in a second. No, I guess scene component is part of core minimal or pawn. So there's VR tracking center. Then we have a U camera component. I can't spell. I believe in camel case, so I don't know why I capitalized things when I was doing this, but it's not important. This we do need to import. You can figure out where these imports are located by simply searching for them. Unreal's online documentation is pretty good. So the camera component, for example, I looked it up and it tells me its hierarchy here. It also tells me what I need to do to include it. So here's its include, and here are all of its functions and variables and stuff. So I need this include to get this to import. So this will add my camera, and now it's green, which means that it found it. I need to add other things like I do want this one output text so that I have something that's attached to my face that will print things out, because if I'm in VR I can't see the log. So this is a uText component or text render component. star output text. This I also need to import. I happen to already know that this is the import for it. Then we need the controllers. U motion controller components. How nice of Visual Studio to finally autocomplete things. U motion controller components. This you import through here. The only reason that you can import this so simply, and we'll actually see this later because it'll become important later, is that by default in the build.cs file, they include this library called head-mounted display, which has all of the information that you need to import motion controller stuff that's related to VR. So U motion controller components, left controller. I need the right controller as well. Still not happy about something. Motion. I have yet another import that I need. Oh wait, no, I found it. Visual Studio sucks, but you don't have a choice but to use it. Also, I don't know, I mean, there are settings in Visual Studio that are supposed to make it work faster, or like autocomplete faster. It uses this thing called IntelliSense, which is not intelligent at all. I worked on hundreds of C++ projects, and I can probably count the number of projects that IntelliSense worked correctly on one hand. But, you know, that's how it is. I find that it's bad in the headers, but it's usually okay in the bodies. Anyway, here are these controllers. Oh, by the way, you can compile by doing this. You can right-click the project and do build. Rebuild is for if something went horribly wrong. Clean is basically... Rebuild is basically clean plus build. Clean deletes a bunch of cache files, build will rebuild them, or it'll build them, and rebuild will just do both of these in sequence. You can also build it from up here, but I find this to be faster because I can right-click and do it quickly. Anyway, moving on. I had some meshes, use static mesh components, Raygun, for my giant Raygun. I had a left cone, and yes, I know that the capitalization is it's very inconsistent, but I'm just keeping it like that so that this entire lecture is consistent with the class lectures. Use static mesh component. I don't know if I need... I don't know why I chose this one specific part to complain about. It highlighted it blue though, so maybe it'll be fine. Otherwise, I do know the import that I need for this. No. Yeah, I guess static mesh component is also in core minimal. Alright, so I have declared these, but as you'll see in a second, that really doesn't mean anything at all. So, well, okay. If I drag this in, first of all, you'll notice that it didn't do anything. I don't see any of those things here. But more importantly, yes, I did declare these things in Blueprint, but I also handled their parenting structure. So, let me explain the first problem, why you don't see any of these things. Well, there are two reasons. The first is that to get anything to appear in the editor, you need to use macros like uClass, which is for classes. For these things, which are variables basically, you have uProperty. So I'm just going to copy this from another project. You need to add a uProperty like this right above the thing that you are trying to add. So uProperty is a macro that just exposes something to the interface. In this case, I used a couple of options. I used edit anywhere, which means that I can edit the information for this object inside of Blueprint, inside the editor, anywhere. Blueprint read write means that Blueprint can actually see and edit these things inside of an actual Blueprint. And category just categorizes it. So, like for this thing here, you have categories like defaults, override settings, rendering. These are all categories. So you need one of these for everything that you want to expose to the interface. And I want to expose all of these things to the interface so that I can actually use them. And when it turns purple, that means it's good. Look at this delay. It's like the worst possible autocomplete, and this is a fast CPU, so I don't know why it's so bad. Anyway, it compiled. And this will kind of solve the problem. We can at least see these things now inside of this category that I called hide, but they're not in the structure here. I want them to be here so that I can move them around as I want and you know, edit them. Like in the blueprint version of this VR class from the original lecture, I get a structure like this. And if I want to move things like my output text, I can do that easily because it's here and I can just move it. And so I can't yet do that in the C++ version yet. And there is a reason for that. First of all, something to think about is, yes, pretty much all of the components that you're going to be using are pointers, but how do you differentiate between a pointer to a component that this actor actually owns, such as these, like this Nick VR pawn owns these components, versus something that is actually a pointer to some other component in some other class? As far as the header goes, you actually don't know that, but there are some functions that are built into Unreal that are used to initialize and handle the ownership of your own components, and also handling the attachment. So like, you know, the actual parenting structure, like head as a parent of head and the motion controllers are parents of the tracking center. That's the most basic VR character structure. The text is a child of the head, so that when the head moves around, you always see this text in your field of view and things like that. All of these things you need to handle in C++ yourself, in the constructor. So the constructor is here, and the constructor handles everything that needs to happen before the game starts, such as setup. And it's called whenever you compile or whenever you throw an object into the scene, or also the beginning of the game. The Unreal compiler or the Unreal constructor is a lot more powerful than Unity's because you can also use it to interact with other things before the game even starts. Like, I don't know, do I have a good example of this? Probably not in this project. But let's say that let's say before the game started, I wanted my C++ class to find all of the pickup cubes, all of these pick-upable cubes that are in the scene. I can do that in Unreal very easily with the constructor. But in Unity, I think they try to discourage you from interacting with other game objects in the constructor. But anyway, those more complicated uses of the constructor we won't see. But what we do need to do is initialize all of these things and handle ownership and attachment. So the way that you do that is with a function like this. So I'm going to copy from another project so I don't have to type it all out. All of these things that, get rid of these. All of these things that I declared, I need to initialize with this function, create default subobject, which will create an object of this type and of this name, and it's a subobject, so it's attaching it to myself so that this actor is the parent of all these things. And so you absolutely need to do this, otherwise you won't have those things. You won't have any of these components. Let me delete this. You might have already noticed that it already worked. So it did add these. The parenting structure is not right yet, and there can only be one root, which is why it already chose the VR tracking center as the root simply because it was the first thing that was enabled or that was created, and there can only be one root. I didn't actually do that, but it is supposed to be the root, so that's fine. Anyway, you can see it actually did add these things, and now that I have a root that is a 3D object that's exposed, I can move my pawn around, and I can also move around each of the subcomponents, which are down here. For whatever reason, it decided to put everything below the actual root. Let me do this. So the only thing that I can see right now is the camera and the text, because when you add these things normally they have some visualization already, and text always initializes with the text, but I can't see anything else. All of the meshes and things like that are empty. And sure, you could just initialize them here, like if I want this to be a cube. But the problem here is that if I ever delete this character, this cube was not created as part of the class definition, so if I delete this character, or if I respawn them, or if I add new networked characters, they won't have this cube. So we need to handle this in the class definition. But one problem at a time. First, let's create this parenting structure. That's right here. So to do that, let me put this back here. To do that, I'm going to delete this temporarily. To do that, we have this function called setUpAttachment. So again, I'm going to copy this from my other project, just so I don't have to type it all. These things don't exist yet. These should. Anyway, there's this function called setUpAttachment, which basically parents this to this. So the head is a child of tracking center. The text is a child of head, and so on. And so the setUpAttachment function just handles this entire parenting structure. And even though Visual Studio complains about a lot of things, I honestly don't trust its errors at all. It's much easier to tell if you have errors by building the project than to try to figure this out. Sometimes it works correctly, sometimes it doesn't, and it really is just random. But anyway, I have setUpAttachment so that it creates the structure. So if we look back into the project, I throw this here, yay, I have the structure that I want. See? With the exception of these texts that are actually not useful. I made these after that lecture. We do have this parenting structure here. So yay, that's one problem solved. The other problem is our meshes. Very quickly, I want to mention that when you create a C++ project, it creates this extra button up here, compile. Compile, so it's a little bit weird and inconsistent. Compile does the same thing as right-click build does here. And you can compile things from the editor or from Visual Studio. And which one actually ends up working is really inconsistent, and sometimes it breaks for no reason. Right now, if I build this, well, I didn't change anything. Yeah, this just to force it to recompile. So it's going to recompile it, and then I heard a noise in Unreal, and it mentions that it hot reload. That means that it did actually replace the code that it's using right now with whatever Visual Studio just compiled. Sometimes when you compile in Visual Studio, it doesn't actually update in the editor, which is really annoying. And when that happens, or just in general, it's usually easier to just hit this compile button. They do the same thing, or at least they're supposed to, but sometimes they don't. I mean, that's just how it is. C++ is a very finicky language. Anyway, moving on. I don't have any meshes still, which is a problem because I want my Raygun. Speaking of, let me import my Raygun. My Raygun is VR. I'll steal from another project. Contents, Rayguns. I'm pretty sure my Windows Explorer is messed up, so it's not updating immediately. But anyway, I created Rayguns, and now I have Rayguns. And the reason that it's gold already is because in the other project that I was using, I told it to use gold, and gold is one of the starter content materials. Moving on. But in any case, I want to handle the initialization of all these meshes in C++, because that's what we're here to do. So that I can also do in the constructor, as I can do with pretty much any initialization task. So I'm gonna put these all next to each other, and maybe at some point Visual Studio will get rid of these squiggly lines, maybe it won't. It actually does autocomplete, I believe. This time it just doesn't feel like it. Whatever. We won't worry about it for now. Anyway, we want to initialize, or we want to create the materials. So to do that, you need to first load the material. So if any of you used Unity for the 590 assignments, you would remember a load object, or I believe it was called load asset from database or something like that, where you can load prefabs and materials and things like that from the editor itself, like you can load the Raygun specifically. Unreal has a function that's basically the same, which will do that for you. So as an example, copying this from another project, you have a function like this, which will find an object, in this case a mesh, and load it into this thing that I called loaded object from this path, and then I can use it to initialize the mesh for the Raygun. You can get this path, I guess I'll quit at like 6. Or I'll quit right after I load the meshes and materials. I think that's a good place to stop. You can get this path by just looking here. So you can see game Rayguns at the path up there. Also, another thing you can do is right click and do copy reference and paste that here. Text static mesh. I think it's supposed to go here. Yeah. Constructor helpers we do need to import. It is somewhere here. Here it is. It's this imports for constructor helpers. I don't remember if you need to import something for static mesh. I guess not. So this will load this Raygun into this object. But now I need to actually tell my Raygun that it needs to use that mesh. And I can do that by doing Raygun, which is of type static mesh actor. Why is autocomplete not working for me today? This Raygun. By the way, those of you who are familiar with C will know this notation for arrows. Arrows are basically the same as the dot in Java, except you use them specifically with pointers. Like this dot Raygun won't work because this is a pointer to self. And Raygun is also a pointer, so I can't just do Raygun dot something else. You can see it actually auto-corrected it for me. For things that are pointers, which will be the majority of things that you work with, you should use this arrow notation. Anyway, I'm just gonna, because autocomplete's not working, I'm gonna just copy this. So here, I'm telling the Raygun to set its static mesh to be this thing that I loaded. Okay, so I'll build it and see if it complains. I don't think it will. It's just being very dumb right now. It is done, and you'll see the hot reload message, and I also heard a little noise. And it won't update immediately, but in Unreal, the default, if you're using something that's not default, you'll see a little arrow here that's to go back to the default. If I click this, it'll load the Raygun. See? Also, in this default character, or in this old blueprint lecture, I added cones to my hand so that I can tell which way my hand is facing. And that I can do here. I have this code. So I am doing the same thing basically. I'm loading the basic cone into something called cone, and then I'm telling both the left and right meshes to use that cone. And that will load the cones the same way. I didn't compile it yet just because I don't want to wait for that. To set up the material, actually maybe I should compile it just to show you. So if I compile this, the cones won't have any materials. So left cone, it'll just be this gray default material. I actually wanted to use a white material because the default material looks weird. So I wanted to use, where are they? I wanted to use this white material. So to load the material, I can basically do the same thing, except instead of using static mesh, I would use a material. So here is loading the material, and I'm loading this gray material to use for this. And I have a function that will also set the material inside of a static mesh component. So for the left cone and the right mesh, set material has two parameters. The first is the index of the thing that you're loading material for. The reason you have an index is because a lot of meshes have multiple material slots. Like for example, if you have a mirror, for example, you might have a material for the outer rim, like it might be wood, and then you have a different material for the inside classy part. And those could be two different materials, or you can use like a reflectance map or something like that. Anyway, the cone only has one material slot, so I just load it into slot 0, and I load it as gray. And this will work, and if I create some new character, you'll see that this will already be gray. C++ class. Yay, it's this gray material. They are too big. One thing that's nice though is that VR preview will just work. So if I play it, it's very unhappy about something right now. I hope it doesn't crash. That's very interesting. Well, just gave up. I'll reopen it quickly. Oh, it decided to save at the exact same time that it was playing. Or no, this is something different. I can't even tell. I have 4 Unreal instances open. Anyway, let's wait for this to load quickly. I just want to set these things on my hand to be right so that we can move on next time. Unreal's acting a lot like Unity right now. I don't know what's going on. You can also play it from here, local Windows debugger. This should load it. And it will also tell you if it's crashing while it's loading. It doesn't seem to be. It's just not doing anything. Is SteamVR working? SteamVR is working. Maybe it doesn't like that I have other Unreal projects open. I don't know. I just know that it's very unhappy about something. Try again. Alright, I guess it was just one of the other Unreals must have locked some asset. Oh man, they didn't save. I don't need these. What was I trying to show? Oh yeah, I wanted to show in VR that the cones are way too big. Oh, and it's also using the first person character, because that's what it's supposed to be using. For this, we can just tell it to, instead of using the first person character, to use mine. I'm gonna just make a quick blueprint class for game mode. Game mode. And tell it to use my home player default pawn class. And tell it to use this one. Okay. Anyway, here are my hands. And you can see the cone is gigantic and it's not pointing the right way. For the one that was on the gun, I actually wanted it to point... I wanted it to be at the tip of the gun so that I can have the pointy part of the cone point in the direction that bullets should shoot to make the math easier. The other one should just point to where my hand should be. But it is not. I actually don't know where it is. I think it just lost tracking. Oh, I know what the problem is. The problem is that right now, when it initializes this character, it initializes both hands to be left because I didn't tell it otherwise. So right controller is still right. And again, we want to change this in C++ because that's kind of the whole point of this, and because otherwise if you tried to change it right here, then when you spawn the character, spawn a new character, it won't have changed. So in the constructor, we can call some functions that will do this for us. They are these functions. So you need this class. So the motion source is which hand it's coming from, or if you have vive trackers or anything like that, it'll be the ID. There's a right hand and a left hand source ID. You need to import this. Where is it? XR controller base. You need to import this to get it to actually find these. And because I'm running this right now, I can't actually build it while it's in. I can't build it from Visual Studio because it'll shut the game off. So I'll compile it from here instead. And if I create this character again, it will now initialize that as right. See? Cones are still too big, and this is actually what Blueprint would be useful for. Even if you don't want to use Blueprint to program, it's still useful for positioning things, which is probably why with the first person character they still have a blueprint of the character, even if all their code is in C++, because as you can see they used it to position things. In the viewport they position the arms and other things because it's just hard. C++ doesn't have a visual editor for these things, but just for the sake of doing it, because I want to show you how to do all the things in C++ that you would need to do. I will do it in C++, just to appease. So in the other in the other original Blueprint project, I already had values that I was using, and I can still use those values. You know, you can imagine how much effort it would be to try to do this manually, but I happen to know these values already, so I just put them in. For the Raygun and the cones, I set their locations and their scales to be the right thing. So cones should be smaller. They were rotated a certain way so that they point forward, and the left one specifically I moved to the front of the gun. And these are relative because I don't know which way the character is going to be pointing when the game starts. Anyway, let's check, or I'll play it since I have a game mode that initializes this person for me. I have my two controllers. I have the left one, and you can see the cone is now pointing the right way with these values that I happen to know already, and this cone is also pointing the right way. Now, I'm going to leave off with just this very last thing. So yeah, positioning these in C++ accurately is pretty much impossible. So what we can do instead is create a blueprint subclass that we use just for the positioning of these things. So I can right-click this and say create a blueprint class that extends the C++ class, and I'll call it VR BP pawn. And you can see this is a subclass of this C++ class that I'm working with right now, and it has all of these things. And yeah, they're already initialized because I set them in the constructor. But let's say that I didn't. Let's say that I got rid of these and recompiled. They would no longer be in the right place. Well, I already created this subclass. Yeah, it doesn't matter much yet. I already created the subclass when it was positioned in that other way already. So this doesn't do anything, but let's say that I did want to position these automatically. So let's say that I wanted to position these outside of C++, but with the blueprint instead. Let's say that I want this cone to be in front like this. Just for now, for the sake of example. In Blueprint, obviously, I can position this very easily, and if I want to now use this Blueprint subclass, I just tell the game mode to use that one instead. And all of my code is still being done in C++, but I'm just using the Blueprint for positioning, because it's easier. So my game mode now knows that I'm supposed to be using the BP one that has fixed transforms, and you can see that it is in fact using the offset cone. And it's just too hard to position things in C++, so this is the common way of doing it. Yeah, that's going to be it for now. And one of the reasons that I recommended people not do the 590 assignments in C++ is exactly this. It took so long just to do the basic setup.
Quick question.
Yeah.
When you were loading the meshes, those things like loaded OBJ and cone and gray mat,
Yep.
what exactly would you formally, like, what are those?
These are like, it's basically creating a pointer in C++ to these exact things in the content browser. So Raygun is exactly this Raygun.
Okay.
And
But you're initializing it there on that line, right?
yeah, I need to load it so that I know what to set as a static mesh, because like you can't just set the static mesh as a name or anything like that. You need an actual pointer to an asset that exists.
Okay.
And the reason it's static is because, you know, you're loading something that already exists, right, in the editor. You can't just change what a cone is inside of C++, or at least you're not supposed to. So they have you load this statically, basically creating a pointer to that exact asset. The reason that I knew that this is an engine asset, so it's not actually in my game, but if I throw a cone in my scene and I look at the static mesh, I see that there's a cone here, and you can right-click so you can see the path right here, but you can also right-click, copy it, and paste it here too. So, you know, it'll give you this, and you can throw that in there. And there actually is no difference between either of these ways of loading it. Like, you can just use the path by itself like this, or you can use static mesh, whatever, this thing that got copied automatically. They both work. I don't know. This is what it copies automatically. So I don't know. Either one works. It just depends on whether or not you happen to copy it from the editor or type it out, I guess. But they do the same thing.
Okay.
Yeah, as I was saying, the basic setup has taken so long, and that's why I didn't recommend people do the C++ or the assignments in C++, because if you don't already know how to do things in C++, it just takes so long to do the most basic things. The code that we'll do later will be a little bit more manageable, but today we just did the setup code, which is the least fun part, and next time we'll do the actual VR code that we need. So if nobody has any other questions, then I'll just kind of hang out. I'll close my